In this video, we're going to talk about inverses, but we're going to look at basically some cases that we didn't get to look at the first time when we looked at inverses, particularly radical functions and rational functions. So let's just recall from when we talked about inverses the first time. We're really going to focus in on a couple key ideas. First of all, the steps for finding an inverse. First step, you would rewrite f of x as y, whatever the function is. We'll go ahead and refer to that as y. Then we would switch x and y. We would then solve for y. And then lastly, we would call it f inverse instead. All right, again, using whatever graphical notation we'd have to worry about. Now, the other thing I wanted to recall from that section is we had to have this idea that in order to find an inverse, the function needs to be one-to-one. And you might remember that one-to-one means it passes the horizontal line test. So we have issues with certain functions not passing the horizontal line test. So in those cases, we need to make it one-to-one by restricting. Now, we did see an example of that previously, and we'll see another one in this section. So let's look at this example. This is to find the inverse of this quadratic, and they showed it in both forms. So you might remember that this form is vertex form. So we could see that the vertex of this particular parabola is 2, -3. And then the second form, sorry, I realized I kind of drew that a little too long. The second form is standard form. That's the form we've seen for years and years in algebra. And if you're given your equation in standard form, it's wise to go ahead and find the vertex. That looks like 2 A's, and it's supposed to be a D. My D's are kind of looking like A's today. There we go. Standard form. So it'd be wise to find the vertex, and you might remember the little formula for finding the vertex is -b/2a. Find the vertex and then put it into vertex form, because vertex form is going to be easier to work with when finding the inverse. Okay, so as I just said, we're going to work with this form, and we're going to find the inverse using the steps. So first thing I'm going to do is rewrite f of x as y. Then I'm going to switch the x and y. And now I'm going to solve for y. So to do that, I'm going to go ahead and add the 3 to the other side. X plus 3 equals y minus 2 squared. And then I'm going to take the square root of both sides to get rid of the squared. And when I take the square root, that introduces a plus or minus in front. So I have plus or minus the square root of x plus 3. And now I just have y minus 2. And then I'm going to add the 2. And I'll put that in the front. And there we go. Now, I'm going to pause because I ignored the second fact. And the second fact is that when we are working with our functions, they need to be one-to-one. And this function, because it's a parabola, is not one-to-one. So if I were to have graphed this, it has a vertex at 2, -3. And it's facing upwards. And I'm not going to get super specific. I'm just going to roughly sketch it. Okay. I really only want half of the parabola. So I'm going to divide it so that I take the positive half. So I'm going to get rid of the negative half of the parabola, positive half only. That means that I'm working from 2 to infinity, or you could say bigger than or equal to 2. X is bigger than or equal to 2. So I'm working with the positive half only, which means in my final answer here, when I rewrite it with the inverse notation, I'm going to write the positive only. No plus or minus. So 2 plus the square root of x plus 3. And we are restricting f of x to be from 2 to infinity. Wow, that is not how you spell restrict. Restrict f of x to have domain of 2 to infinity. All right, great. So we kind of saw that before. We did look at a parabola previously. Let's look at a more exciting example. Ooh, a cubic. Okay. So for this one, I'm not going to need to do any sort of special form. The way it is fine. I'm just going to go ahead and jump on in and follow my steps. So first, making f of x, y, switching x and y, and then solving for y. So that's going to be x minus 1 equals 5y cubed. I'm going to divide by 5. And then the way I'm going to do that is I'm going to actually write it as a 1/5. Let me see. I think I'm going to, oh, no, I don't. Here, let me put it over here. So I'm going to write 1/5. You know, I could leave it. I'm going to leave it. It's fine. I don't think that's really going to help. And here's why. The next step is why. Because in the next step, I have to take the cube root of both sides in order to get rid of the 3. And I might as well leave the 5 as a denominator. There's nothing wrong with that. I don't need a plus or minus for odd powered roots. So that's it. That's my inverse. And cubic functions, they are 1-to-1. So I don't have to worry about restricting the domain. So there we are, the inverse. Okay, so the last example is probably really the big point for this section. This example is a little bit more complicated. It has a rational function. So I'm going to go through the process of y equals x plus 3 over x minus 2, switching x and the y. That's going to then give me y plus 3 over y minus 2. So both the x's become y's. Okay, but here to solve this, we're going to have to clear the fraction. Like I have no choice. I got to get rid of that fraction. That's just making life difficult. So I'm going to multiply both sides by y minus 2. So the problem is I'm going to have to mix up my x's and y's a little bit here. So I'm going to distribute x in. So that's going to give me x, y minus 2x equals, okay, now these cancel. That was kind of the point, and I'm left with y plus 3. So here's what I'm going to do. I'm going to get everything that has a y to the left side and everything that doesn't have a y to the right side. So I'm going to add this 2x and bring it over here to the right side. And here, while I'm at it, I'm going to minus this y and bring it to the left side. Okay, now I can't actually minus xy minus y. I'm just going to write that, xy minus y. That's gone. That's gone. And then I'm left with 3 plus 2x. Okay, great. Now, here's the trick. Now that I have the y's on the left side, in order to get one y, I'm going to factor out a GCF of y. So that means that if I factor that out, I'm going to be left with x minus 1 equals 3 plus 2x. And now I can actually isolate the y by getting rid of the x minus 1 and dividing it to the other side. So what I'm left with is f inverse equals 3 plus 2x. Oops. Yeah, that's right. 3 plus 2x over x minus 1. And I could write 2x plus 3, by the way, put it in descending order. There's no real reason to leave it not in descending order, but there's also no problem with leaving it not in descending order either. But there it is. That's it. That's the answer. So to do these, it is a little bit trickier than what we've seen before. We need to go ahead and clear the fraction, and then we have to end up factoring out that y in order to get it to work. But there you go. The rational function, by the way, has no issues with being not 1-to-1, this particular rational function. You could graph it just to make sure, but yeah, we're good to go. And that's it.